From the interviews, it became clear, as it does from the international literature, that Industry 4.0 exerts its greatest impact on production, and that the companies surveyed have also developed varied methods and procedures around it. Welcome to a new video where we're going to talk about the industrial evolution, Industry 4.0, and its connection with technology and consequential effects that have been happening so far. This is following up a study we've been actually dissecting so far and looking through it alongside the way. So go check out everything else, but stay and connect. This can be termed first category when sensors are built into a machine, and sensors are incorporated into the process of monitoring a production process and indicating deviations from it. The B2 examples, or actually the interviews of this study, shows how a company incorporates a sensor in the ejection molding machine, which indicates if something stops production. It then sends a notification to the operator's mobile telephone, then the intervention is required. We have something interesting about the companies interviewed because they have different experiences, and also around the four companies they have a purpose to illustrate all the technologies and solutions alongside this technological advancement. Among the companies, there is an SME belonging to a majority owned Hungarian holding company in the electronics industry, two multinational large automotive companies operating in the automotive industry, and a multinational automotive company functioning as a system integrator. The value chain approach seems to be appropriate since the companies have a functional structure, even though they have realized that Industry 4.0 developments have to be handled at a cross-functional or company group level. Generally speaking, Industry 4.0 has been more noticeable in the international companies, while the Hungarian SMEs, although it has begun development on that year, prefer to wait until the technologies are the most successful are revealed and until the purchase price falls. For example, is when you also buy a new phone. I want to put something larger into the smaller perspective. Sometimes people just don't want to pay for the newest phone. It's going to be more expensive. Perhaps their functionality is going to be the same. The new acquisitions to the phone are like pretty similar to the previous ones. So people wait until the new model of the phone, of a phone line, drops into the market in order to get a previous model on the same line. And this happens because sometimes prices are too high. That we were talking about in the previous video, that investments are a risk, not only on banking, not only on housing, not only in education, in a variety of industries you don't even have a clue of. One of them is this one. When the companies want to get immersed into the newest technology, some people tend to say like, no, that is a must. They need to buy new machines, they need to advance. But that's also a risk, because if you want to jump into the new age of technological advancements, you literally need to go ahead of your competition. That means if you want to go first or be one of the first, you need to invest on it. But you still don't have a clue if that's going to work for your company, because you don't have actual studies around, actual life cases around. So that's the thing with that. That's why it is a risk. Even in these fewer factories, you don't know if it's going to work. You don't know if it's going to be something very valuable for your company that is going to make greater good than bad. And that's why sometimes this is the safe option to just wait until others they test it, they say like, hey, this is great on a very similar the same industry you're at, and then you purchase the not that advanced group of kits and machinery and others, but you still are on the loop with the previous one. It happens the same. The companies have different degrees of affinity to Industry 4.0, the ones in this study. One company makes the necessary improvements but does not move forward, does not pilot it, and takes advantage of what is afforded by cheap and easily accessible technology. We have heard of a company like that in the past. There are two companies, really Hungarian factories in the group of companies are pilot factories creating ideas, transformation, and developments. And what works is transferred to other factories. We have had work with a group of people like that in the past. The creative, the innovative, like let's use what's latest, yes or yes. Let's be ahead of everyone else. Let's make history. But what about also there are local standalone initiatives, and it can be stated that a lot depends on dynamic leadership. So these companies are a great example of what happens in a lot of companies around the globe at the same time. Even in a more smaller perspective or local perspective, you can find a company like that. So an exercise that you can do is like going out, find out more information about a million company in your town, in your city, that you can pick that have been going around for some years, and try to map out like how do they work, if you can find information now, if they are like actually being ahead of throwing off any advancements, if they're appear on the local papers, what do they say about them, then you can see which one which type of company it is. The innovative activity of one company has led to the development of digitalization before the launch of the German high-tech strategy, for example. So that's like I'm going to be ahead of everyone else, but for real. And when the companies ask, it was identify three behavioral patterns. One approach progress can be achieved by taking only the low-hanging fruit, alternately. But also, there can be the intense internal motivation, which can even help a subsidiary of an international group of companies. Thirdly, the company can socialize into an innovative environment where a high degree of innovation is expected, in which all members of the group participate and the results are like lovely. It's like also some companies they fund a research group, which is also like important in order for you to be ahead of everyone else. And also for other people to buy, communicate, and integrate your ideas. That's when you make like a huge difference or impact as well. The first step is that the companies start collecting data. We have them nowadays. You can have like some kind of on-site survey. You can also have the cookies on a website. You can have a form filled out by people in different environments, public environments, private environments. You can also have the verbal questioning from one coworker to another or from one person to another outside your work, and start documenting that, and let me know which other examples you can come up with. But yes, collecting data. Nowadays data is super important and it's literally gold. They install the technological tools or software that can capture the desired observations and collect data. Performance immediately increases by 30% if we start observing a process by cameras and sensors. That's why people use it also in sales to know what people uses the most, what people purchase the most, in order to increase sales also by percentages, goals. It is used in marketing in order to increase the number of visualizations on different platforms or media itself. But yeah, people can use it also internally on a fabric as well. The second step is to transform this data into decision support information. We need to build up a serious IT infrastructure to store and handle the data produced in the manufacturing process. That's what the second interviewer tell us. This is a critical point. In many places, there is a lack of capacity for data analysis and interpretations. The cloud is great, but it can be also expensive for large amounts of data. So there is a lack of professional skills in this area. It is not only necessary to run the analysis, other tasks from the preliminary cleaning of the database through to the knowledge of algorithms. And we also need experts on site or remotely to check those databases to keep them on track, do the proper data analysis, and more. The recognition of errors and distorting effects, to the transparent presentation of the results. All of that is important, all of that requires technology and hands involved. The third level is the use of the results gained from data. As the second interview says, we have specialists at the group level who develop machine connectivity and big data analytics software. And then we go back again. We also have software. That's also something that can be expensive for large amount of people or places, sites, factories, and others. To do this, well-trained personnel are needed who can reprogram software and hardware and write new software or algorithms. That's where I refer in the past people on site remotely who that it is only required to do data management and who are able to further develop the systems, also programmers and other related fields. There is also need for decision-making algorithms and decision makers who can build this information into their decisions and achieve goals using real-time data access and analysis. So a part of that, you also need the person who is going to program the workflows, new commands, in order for the changes to be correctly applied. Because remember, we're not talking about only personal in persons itself. We're not talking about a person. We're also talking about machines, smart robots, and other expressions that have been coming off this paper. That's why it is not that easy, and that's also every machinery is dependable at some point. Essentially, sophisticated methods are needed to analyze the ways in which we can estimate the usefulness of IoT tools in terms of the increased logistics service level, the efficiency of the processes of the business partners, cooperation among certain logistics functions, financial and market performance, and the competitiveness of firms. Therefore, independent sample t-tests are used to determine whether those companies applying one of the IoT tools tend to estimate their utility more highly than peers without them. Here, as the methodology is assumed, the utility responses are normalized. There was also found a significant difference appear between the two samples examined, in which those logistics companies applying IoT tools are proving to be more efficient and have better performance. In the case of CPS and CPPS, firms seem to have a higher level of logistics service, more efficient processes with their partners, better cooperation among certain logistics functions, and higher financial market performance and competitiveness. When using big data, it was found a higher level of service, efficient logistics processes, and greater competitiveness. In other cases, it was found no substantial differences among the main differences. So being on track with technological advancements can be also beneficial or maybe not. But you can have both scenarios and something in between. But you need to lose something and you also need to gain another stuff. It is what it is. Since the results of this questionnaire are not representative or generalizable, it was the lookout to discover real company cases illustrating how companies interpret Industry 4.0, what technologies they use, and how they are adopted, as well as what problems companies perceive, perhaps in addition to those related to cybersecurity. This is a way for you to document your questions and the answers you get. It's great for people to knock on the doors and see who opens and if they even open that door at the other end. So I encouraged you, if you have questions, you can also document those. You can also do a paper or you submit what you got based on your main question, because yes, investigations are needed even if they are not in a general aspect, exponential or replicated, but information is information and well documented is always appreciated. The interviews were semi-structured. A list of questions was used, but if interviews wanted to discuss something in detail, they did not follow the list strictly. We are humans. We can go into one area or topic in particular and then move to our primary school memory out of the sudden. So I always like that kind of flexibility on the papers. The four interviews were then compared along the previously defined topics: interpretation of Industry 4.0, its appearance in production, problematic issues, and the development phase. Which one was your favorite? And remember to go check the previous videos because you're going to hear them all. It was also asked various industries about the use of new tools, their benefits, disadvantages, and the causes of security issues that may arise. Have you ever heard of CPS, CPPS, Big Data Analytics, or others? If any of three, please let me know in the comment section. In order to exemplify the robustness check of the estimations, it was used a different number of methodologies to measure the usefulness of various IoT tools in terms of Industry 4.0 technologies. On this paper, besides various descriptive statistics, independent sample t-tests were frequently analyzed to highlight the differences among the evaluations. The hypothesis those logistic firms applying IoT technologies were evaluated as having better logistics and financial performance than those that do not. But it is also important to inquire whether the companies under investigation, and I want to add, even the ones that are not, are planning or work planning to introduce new technologies over the next years and wide. It is likable to access the application of new technologies among companies around the globe. So we need studies like this, documentations like this one. So what do you think about this paper in particular? Or this specific information of people applying 4.0 industry technologies or advancements in their own way? We always think it's like the same phrase for everyone, the same way to introduce it for everyone, but it is not. And when I say everyone, I mean every company, every factory, because we're talking about large landscape levels. So, yeah, what's your opinion about it? Did you know that 4.0, Industry 4.0 wasn't linear? Let me know. See you on another video. Bye bye.